Hello.
Howdy, howdy. How we doing?
Hello.
Hello, good evening.
Is your name pronounced Salish?
Yeah, hello. My name is Shailesh. I'm joining for the first time, just found out this project recently.
Fantastic.
And
Shalish, I'm David. You're Mark and Dan in the call as well. Very nice to meet you.
thank you. Nice meeting you too.
All right, it's 5 past. Do you want to maybe get started, or are we waiting for some other folks?
I think feel free to get started.
All right, do we have any volunteers to host the session?
Okay, I can do it, I guess.
I think I'm gonna pass this up. I've got some other stuff I need to take care of.
Might be a pretty quick one today.
No.
Yeah, just are we already recording? Looks like we are. Okay.
Yep.
Well, then I will kick it off. So, welcome to the Hyperlight community meeting. It is September 17th, 2025. And this is a CNCF meeting. It means we follow the CNCF guidelines. If you have CNCF code of conduct is essentially being respectful to each other. If you have any questions or concerns about that, please raise it to any of the admins. If you have any questions or want to speak, try to raise your hand, and we'll go ahead and get started. So, looks like we don't have a ton on the agenda today, but we do have a new member, Shalish. Do you want to say hello?
Hi, good evening.
How,
I
what brings you here?
I am a site reliability engineer in India, and I work in a fintech company. So I was looking through CNCF, and I was looking for to contribute somewhere. So I have free time, and so I found out this project. It has something related to container runtimes, and my daily work involves working with Kubernetes and all. So I thought that okay, I can try. If I understand it, then I'll contribute. And you have regular meetings, so it'll keep me in the loop. I thought that okay, let's try and try to understand what you're trying to do. I went through your code base. I made one bug fix recently, and yeah, so just looking forward.
Awesome. Well, thanks for the bug fix and thanks for joining us. Look forward to having you with us.
Thank you.
Also, there are aspirations to get closer into the Kubernetes ecosystem and start to have more connection with Containerd. So if that's an area that you're interested in, happy to chat more about how that kind of integration could work. Maybe dive into where you're interested and we can talk through any places that you want to start, anywhere that you'd be interested in getting involved. We're just really happy to see new faces around. So it's good. Thanks for dropping in.
Yeah, sorry, I'll share my video.
Oh, no worries.
Oh yeah, that's optional.
Totally optional. Very nice to see you.
Yeah. So yeah, I work as an SRE, and my usual work is maintaining systems. So when I saw a container runtime project, I thought that I work with these things daily, so maybe I'll understand, and I can, because I don't really know. We use these technologies every day, but I don't know how they're actually built. So I thought that okay, if somebody is building a new thing, I'll try and understand whatever I can.
This is this is interesting. So, do you have any questions? Anything that you got a bunch of folks here that have worked on the project. Is there anything you'd want to chat about? Because we don't have anything in the agenda. So, James, do you feel like this is okay?
Yeah, absolutely.
Yeah.
Yeah. So there was this bug I found in. So this was reported in the GitHub issues. I thought that I'll try to pick it up. I When I ran the code on a machine, I think it's already fixed. So, but it's still mentioned in your in the discussions that it's not fixed. So if you can explain, like I've read the code, and if you can explain, just guide me, like tell me this is where we have to look. I'll try and look into it more, and maybe I can push a fix for that.
Sure.
I'll,
Which one is it?
just 1 minute. Issue 497. I'll paste it in Slack if that's okay. Or here only. This one. So I ran this code. The error that's mentioned here, I didn't get that error. So what I got is uh,
Ludwig is on the call here, and I think he
Oh
put
yeah,
in a temporary fix for this, but I don't know what the long-term solution was.
yeah. I just changed the logging level of that function or those functions to not be error levels anymore since they errored like unconditionally. I think that was in PR 662. Um, but I also have another PR out that just restructures error handling in general, and that will get rid of this permanently. So yeah, I think this issue should go away soon.
And Ludwig, do you have a PR to reference there?
Yes. So 868 is the one that's open.
Cool.
And the temporary fix for this one was 662.
So, looking through the fixes that Ludwig put there, that would get rid of this, might be a good way to just start reading and understanding maybe why the changes are made. But we could also potentially look for another good issue if you're interested in.
yeah,
Picking
that's
something
not a
up.
problem. I'm still reading the issues and the code, and when sometimes when I get time, I read the ERs that you raised. Okay, I'll find an issue and being in the channel and find that I can do it. So,
Uh,
About this project.
274 might be a good one.
Okay. If I understand correctly, this project is like something like Azure Functions or AWS Lambdas, right? Just to run uh, a code in a sandbox environment and to cage it basically. Or am I wrong? Because
You are now asking the really good questions. So you're on the right track. Yes, it is about hypervisor isolation for running code. So when you think about hypervisor, are you familiar with Kata?
sorry,
Are you familiar with Kata containers? Kata?
no, I'm not.
All right, Kata, and let me grab a
Firecracker.
link.
Have you heard of
Yeah.
Firecracker before?
You heard of Firecracker before, Salish?
Yeah, I know.
Okay, cool. So Firecracker starts off like a little OS, a little virtual machine, right? And it just the same way as you would start up a virtual machine in one of the clouds or whatnot, but it starts it up. It's a very small, minimal kernel, Linux kernel that starts up within this hypervisor, and it gives you protection to like whatever workload's running in there, so you don't share a kernel between like your host system and the thing that's running your container, right?
Yeah.
So that protects us from like container escapes, getting at memory or syscalls on the host, stuff that maybe you make a mistake and you leave some doors open, and somebody could then gain access to your underlying host OS. And that's where it gets scary, right? They can exfiltrate keys and sensitive information. So the neat part is a hypervisor is really just a virtual piece of hardware. And so we can set up like a set of memory, and we can set up a virtual CPU, and we can run whatever we want in that memory and CPU. So what Hyperlight does is, in the most basic form, Hyperlight has what is called a unikernel. So it's just a very little chunk of code that helps bootstrap an application. So instead of actually having a whole OS in there, we just have your application code, and we're going to just run your application code. So that gets a little difficult, because then we don't have syscalls, we don't have network stacks, we don't have all sorts of stuff. So one of the cool parts about Hyperlight is, yeah, you got this little application that's running in the hypervisor boundary. It's protected. It's not going to be able to reach outside of there. So it's sandboxed, but we can also interact with it from the host side. So you have your like trusted host side, and then you have this untrusted guest, and we can talk back and forth between the two and interact. So that gives us an opportunity to be able to run, functions. And then we can continue to build on top of the basics of Hyperlight to add, for example, a microkernel, or other low-level constructs that help us to build richer applications on top of it. So Hyperlight itself is kind of a foundational piece that provides us this interaction with the underlying hypervisor that allows us to then use that to build larger and larger constructs. So if we wanted to run, say, WebAssembly in isolation, or you wanted to run JavaScript in isolation, or Python in isolation, instead of actually spinning up a whole OS and having to have all of that memory and all the things that are associated to that entire OS, we can just start the application. So hopefully, eventually it gets to a point where it's like, okay, things like Lambda, or maybe something in Kubernetes uses this with like Kata or Knative to be able to scale to 0 and start up functions really, really fast. with very little overhead. So you can have protection, and you can use more of the resources of your cluster instead of having to dedicate them to, you know, running OSs that you don't really need to run.
Yeah,
Does that make
but
sense?
yeah, I understand. So when I read the README file, I got the impression that okay, this you're running a host. On the host, you can run any number of guest functions, and this it to me it looked like okay, this is what AWS Lambda does. You run any function in a sandbox environment.
Yeah, it's pretty close. Lambda ends up again build like running the operating system. It runs a little Linux, and then the function on top of the Linux OS, right? Yeah, yeah. Uh, hopefully, we can make lighter weight functions. Super lightweight. Yeah, and if you're interested in like microkernel stuff, Dan is the person that hacks on a lot of that stuff. Simon, Ludwig, Mark, and James and I are bounce around uh, to Hyperlight and WebAssembly and all sorts of fun stuff.
Yeah, so I have just started, so I wouldn't, I don't want to say anything that I won't be able to do. I am, so I always knew about hypervisors because my job is such that we know, but we don't actually work on it. Like I use it, but I don't know how KVM works. During setting up all of this, I learned lot of these things. But uh, yeah, I'll go through the code and I'll pick up something that is easy for me. If not, then it's okay.
So
I won't do it.
maybe let's take a look at 274, that issue. I think there's probably, it looks like it's kind of adding some maybe missing components, and it might be that there's some examples that you can kind of follow along. And I think that might be a good one to kind of maybe get started with.
Sure. I'll can you just tell me what I'm looking for here? I certain types function don't have.
Yeah. Just a second. So it looks like
Okay, I understand. Certain types don't have function.
Yeah. And so if you look at this particular file here, you'll see that I think it looks like we have in 32 and 30 unsigned 32 and 64. We don't have some of the ones for.
Do you want to share the screen in case anybody's catching up on the recording, maybe?
Sure. Hold on a second, let me pull over this other tab. Okay, yeah, so this issue here is we're missing a few functions for, I think, the CA API. And if we search for this HL guest host return, you'll come to this flat buffer file here. Let me make it a little bigger. And we can see that like there's a bunch of functions in here for int32, int64, but we're missing a few for like the ones that were mentioned. Boolean, maybe doubles, some other ones like that. And so this would be a pretty simple PR to just kind of get familiar with the code base and maybe add some tests. You have examples of how this works, and so you can get kind of familiar with how things run and work. Yeah, see, here's all the to-dos at the bottom of the file.
Sure, sure. I'll take this up.
Yeah. This has got some simple examples and things, so should be pretty easy. But if you have questions, just ask in the Slack like you did previously. I don't know if anybody else has any other good first issues, but I saw that one was late.
I think this is a good one. I feel like it's a good gateway also to like understand how we serialize things specifically using memory. So the guest and host communicates.
Do you want to maybe just quickly describe that, Dan?
Yes, although there is a very loud fan. I'm not sure if that's me or.
Oh, I think it was Ludwig.
Is
It's
it-
quiet.
I still
I'll mute
hear
it.
it. I think. Oh, now it's gone. I think it might have been you, James. All right, sorry. It just made it a little hard for me to sort of.
Yeah.
Now it's back.
Yeah. Okay. So it's me. It must be my computer. It's right here. So it's humming. It doesn't
No, all
like
good.
zooming.
Yeah, it just made it a little hard for me to hear myself. Yeah, so like David was saying, the whole deal with Hyperlight is we have this host. The host, with the host, you can call into a guest. So you'll call into VM. We'll do a VM run and execute code. And to execute this code, we need some sort of communication between the guest and the host. And we do this via shared memory regions. We have input and output memory regions. So, for example, say you call a guest function. The way that you do that is the host, and James is bringing up some, I think, useful graphs here, but the host can serialize a function call into a memory region. We'll do a VM run, go into the guest. The guest can then deserialize that function call from memory, understand what parameters were passed in, and what function it should execute. It will then do this sort of dynamic dispatch mechanism to call a guest function. The function will execute, and then once the guest has a response, it can then serialize a return value into the output memory region so that the host can then read it and then output outside the VM boundary. And the way that we do this communication is via flat buffers, which is what you're seeing in the file, and this is the serialization mechanism that we use.
Yeah, I went through this. I knew about protobufs. This I did not know that. This is new.
Yeah, so they're pretty similar. I think one of the reasons we chose flat buffers over protobufs is just because they were lighter weight. And so, and we could use them with zero copy, though it's not quite zero copy because we're doing that. So right here, you'll see that we need to implement these types. Maybe a good exercise would be to understand what types are supported by Hyperlight. You can look into that in the host. And I think that will probably push you into seeing the regions of memory where we put those things in, and you understand the whole architecture as a whole. I think this is a good first issue.
Cool. Next, Dan.
Yeah.
I guess this is a diagram.
I have read these talks and read it again. And if I have any questions, I'll ask you. I'll ask in the Slack.
Yeah, for sure. I see that you're in the Slack already, so that's a good place to reach out to any of the maintainers.
Yeah.
Any other questions? Or anything just like burning in your mind? You've got everybody here. I think we could probably answer most questions at this point.
Okay, I do not have a lot of questions.
Okay,
So
cool.
what I was expecting is because I was expecting that you may discuss something and then I'll just listen and see how uh, what what is going on.
Yeah, I think we often do. Today's a little quieter, I think, because many of us are working on some side projects. We have a few days to work on some interesting, cool projects that we like to work on at Microsoft, and so I think everybody's kind of focused on those things. So typically, we do discuss various features and releases, and also go over the backlog for things, but. I think everybody was kind of a little caught off guard today.
Any fun topics anybody want to dive into?
Well, one thing we could do is, I guess, go over our current issues. We have release planned for end of the month. We'll go over that first. Be a good way to show some issues that we're currently working on and what's going on in Hyperlight. Do you want to share your screen, James, or do you want me to take over? Anyone else?
Sure, I can do it again. Well, my fan will probably start humming again. But
It's not as bad now. Before it felt like your computer was gonna take flight.
yeah, that's how it feels like. Once I start sharing the screen, it's gonna do
Oh,
that again.
okay.
Just a second.
If you want no worries, I can share, by the way.
Oh, sorry, I was just trying to find the Zoom that like bar that keeps moving and. Okay, cool.
Yep,
Can you
I see it.
see the screen? All right, go to the milestone. Okay. Guess we can start at the top. Remove host function definition. So the Hyperlight WAS module can be replaced by a host function call, which does not require statically deciding. I don't know much about this one. Does anybody have anything? It looks like it was new. 2 weeks ago.
So this is something that I did prior. I removed the host function definition region, but we brought it back again because WASM modules needed it in Hyperlight WASM. But it seems like that's not the case anymore. Be replaced by a host function call, which is not. Oh, okay. Yeah, if that's possible, then it would be great to remove it.
Okay, cool.
And I did this prior, so this that you can just refer to the previous PR.
So this might actually be another good first issue since there's some previous work to.
Yep. If you can see in issue 453 is where I removed it, and then issue 600 is where I brought it back.
Okay. Okay. You said issue what?
453. Yeah, and then brought back.
Which one?
600.
Okay, cool. Panic and host function poisons associated mutex. Ludwig, this
Like,
is something that your other PR works on, I think.
Yeah, I think. Yeah, I forget, but yeah, I would like to address this. I forget if I'm doing it in this PR or if I'm doing it in the next one.
Sorry, which PR was that?
Yeah, I forget. I could comment on this one, James. You can keep going.
Okay, okay, cool. Hyperlight component macros generate the wrong code. This was partially fixed. Okay.
It looks like Lucy's on this one.
Well, she said she has a few other things she's working on here, so. Hyperlight macros. Okay. Impl drop for host resources in the guest. Resource handle. This sounds something related to wit. Lucy's not on call, right? Yeah.
Nope.
Okay.
I don't know if anyone else has context on this one.
I think that's for the wood, right?
Yeah, it's going to need drop implemented. Isn't that so that the host side resources can be cleaned up? Yeah, yeah. So we have to call back to the guest to make sure that when we drop something, or we have to call back to the host to ensure that when we drop something in the guest, no longer use it, that the host can clean up those resources. Yeah, because a resource is just a pointer to and a struct on the other side, right?
Yeah.
And this is specifically to the new wit stuff.
Yeah, I mean, it's actually the same thing in FFI too. Like, say you take a reference to a resource that's on the other side of your FFI boundary. At some point, you need to be able to go and tell the others, like, if the memory is owned by, like, FFI entity A, and entity B has a pointer to, invoke functions on it, it's actually calling across the boundary to invoke. Memory mutates over here, and a return is sent back across the FFI boundary. So in this scenario, we're saying, okay, hey, I'm done with this thing. We need to send a signal back across the boundary to say, okay, cool, clean it up. We're done. The joys of where memory lives and is owned.
Exactly. Okay, sounds like something that we do want to be doing.
Yeah, just looking at the WIT guest that we have as well. There's an interface host resource, and we have a function there, round trip own, where we return the test resource. Maybe adding a text to that to recognize that's properly dropped is a good idea.
Do you want to link? Do you have a link to that? I can just drop it in here.
I'll add to the issue.
Okay.
Feel free to go to the next one. I'll add it in here.
Okay. Yeah, we talked about this one, I think. Just making sure that we ensure all the registers are getting removed and cleaned up. I think we're doing this for most things. I think this was a check to ensure that we are doing it for all of them. On AMD 64. Yep. Okay. And then cleaning up the Hyperhost API. I think we discussed this and we were talking about marking them as depreciated so that we could begin to use them internally. Implement memory mapping. Oh, investigate crash dump features, works with them and mapped regions. This is something, Ludwig, you're looking into with the snapshot API?
No, I'm not looking at this.
Okay. I think we should probably add to make sure that the snapshot is, or I guess, no, this is specifically for crash dump, sorry.
Yeah.
Implement memory mapping. Yeah, okay, so prove guest tracing. I think this is the kind of big tracking issue. I know Doru did identify or was able to fix the last remaining issues, and so I think he's just cleaning up that PR, but it was out this week. Okay. Oh, I skipped memory mapping for Windows. Simon,
I am working. Well, I was working on this. I was on my third implementation last week, and I promise this one will work.
Okay, cool. Okay. Improve guest TLB. I think Lucy said she was working on this as part of some of the features that she was working on with the guest cow stuff. It's not restored under certain error conditions. All right.
I don't think Jorge's in the call for this one.
I guess this might be related to some of the work that you're doing, Ludwig, with the remapping the errors.
Not sure. I haven't looked at this one.
Okay. host mappings to have destructors. Okay, so this is part of the snapshot API stuff. Making sure that API has the ability to clean these things up.
So James, just a heads up, we're almost at time.
Oh, okay. Let's take a look.
How many issues are we missing from?
We will allow host mappings to active constructors. So this enable debugging WASM modules. There was a issue finding clang on Windows, but otherwise it is working. So that's actually in the WASM thing. I think Doru was also just cleaning up how that worked. I think he had a workaround. Remove MSV2 support from Hyperlight. I think I saw we're good to move that forward. Is that right?
I think so.
If we're good for that, I'll do it next week.
Okay, cool. And then support for this. This is a PR that's open. I think it's pretty much ready to go. And then define a common format log for logs in Hyperlight. And I know Doro is working on this one. So I think we're good.
Awesome. Any final questions or announcements from anyone? Yes, James?
I just want to wish James's computer a good last few weeks of life before we finally replace it with something a little more powerful. It truly needs it.
Or before it takes
It's trying to take off, you can tell.
And Salesh, it is so great to have you join us. Thank you so much. Everybody else, awesome work as usual. And good luck in the Microsoft Hackathon, which is going on right now. So this is like our once a year chance to go do something really, really fun and weird and cool. And so that's why we're doing that this week. And sorry for the lack of content there. We'll come back with more next time around, fortnight from now.
Yeah, no issue. I'm glad that I was able to join this.
Hope
Yeah,
to see
great
you
having
next
you,
time.
Felix.
Thank you.
Thanks,
I'll
y'all.
try to pick up the issue and I'll keep you updating maybe on the weekend or during the weekdays.
Yeah,
Awesome.
dude, this stuff's hard. And the Rust is hard, and ioctals are hard. All of this stuff is very complex. The questions are going to come up all the time. Feel free to ping us. Anything we can do to help, we're there for you. All right.
Yeah, I chose this because I have a lot of time after coming home from office. So just I went on CNCF website and started looking at okay, something that I can understand, but which is not hard to explain. I wanted to just do something that was a little bit intricate and this very kernel level memory management and all. At first, I looked at this code and I thought that I may not be able to do it, but then you hold calls every 14 days. So I thought that fine, I'll just join one or two calls and see. Maybe I'll understand. If I do, I'll keep joining. If I don't, then I'll stop.
Okay. No worries. We're here for you though, and excited to see you here. So, yeah.
All right. Thanks, everyone. See you next
y'all.
time.
Cheers.
Bye.